All right, illustrative math, unit 0 is called geometric definitions and notations. So this is actually not a unit in illustrative math, but this is something that I put together just because I think that it's very important to make sure that we have a good foundation of definitions and terms in geometry before we get started on lesson 1.1. Okay, so our goals today. I know the geometric definitions given in the unit 0 note sheets. I can use geometric notation to name and identify lines, rays, segments, planes, circles, parallel or perpendicular lines, congruent angles, or segments. I can use a compass to construct a circle. I can use a protractor to measure an angle or draw an angle when given the angle measure. A lot of stuff. All right, so first thing, let's go through some undefined notions in geometry. So before defining key geometric terms, it's essential to understand the foundational concepts that are considered undefined in geometry. These are basic building blocks. So the first thing is called a point. A point represents a location in space. It has no size, length, width, or depth, just position. So most of the time, a point is, usually pretty small, just like that. Really, technically, although there is actual physical width there, it has no width. You can think of it like a pin on a. You ever put a pin in a cork board? It's so tiny. We usually label it with a letter, so we call it point A. And maybe up here is point B. It's just a location in space. Oops, I guess I should have put that up. Oops, should have put that up here with point. All right, so there's a couple points. Now, a line is a straight one-dimensional figure that extends infinitely in both directions, has no thickness, and is defined by 2 points. It is named by any 2 points on the line, and a line with arrows extending in both directions above it. So a line will look like this. It might be slanted, it might be horizontal, whatever. And in order to name it, you need 2 points on the line. So if this is point A and this is point B, we would call this line AB, and we put arrow right above it. It's supposed to be an arrow there. Clean that up a little. Okay, line AB. Now, we could also write it as line BA. There's no real right or wrong way. It doesn't matter that B is on the right and A is on the left, as long as there are 2 points on the line. If I had a third point over here, let's say this is point C, you could call it line CA or CB. Okay, anything like that. All right, any 2 points that are on line all mean the same line. Now, the other thing that you will also see from time to time, sometimes they'll put a cursive letter here on the left, like maybe a cursive L. We could call that line L also. Now, when it's a cursive letter on the side, you can name it with just one letter. You don't need 2 points, okay? Distance along a line is the measurement between 2 points on the line, representing the shortest path. So, if I just have, let's say I got point P right here and point M right here, the distance between those 2 points is, if I had a line right there that goes through them, it would be your distance right here from P to M. All right, straight line. So, think of like, you take your, where's my ruler here? You take your ruler and, you just take it down here and you line it up. I can figure out how to turn it. There we go. So you line it up right there on the line and measure it, okay? All right, arc length, the distance along a curved line, such as part of the circumference of a circle. Arcs are named by 2 points if they're less than 180 degrees. Call that a minor arc, or 3 points if they're greater than 180 degrees. So, here's my circle here. Let's just put a couple points here. Let's call this point A, call this point B, and we'll call this point C. So we would say arc AB, and we put an arc above it, kind of curved, not a straight line. So arc AB would be right here. Now, some of you might say, well, what about this? I could go from A to B around this way, right? Well, since this is bigger than half a circle, it's greater than 180 degrees. This arc here, and I'll use colors here so you can see this. This arc over here would be arc ACB. We need a third point right there. Okay. So that's arc ACB. So A through C to B versus AB is definitely what we know as a minor arc. Okay. Same thing here. If I wanted to, maybe, let's try some other ones here. I'll keep the same points, but same idea. Let's say I wanted this arc here, arc, this arc, and then this arc. So, the blue one is over half, so that would be arc A B C, or I guess you could do CBA. Either way, it's the same, but have to have 3 points with those. Okay, and then the smaller one would be arc AC or CA. Make sure it's an arc, not a line, or make sure it's curved there. And there you go. All right, some other stuff here. Array. Array is a part of a line that starts at a point called the endpoint and extends infinitely in one direction. So array would look like this. So right here, there's a good ray. Starts at a point, extends infinitely. So you need 2 points to name it. One of them has to be the endpoint. Okay, so this would be represented by start with the endpoint and then put the other point and an arrow. Always start with the endpoint and then go to your arrow should go to the right. So what you would not do, even if your arrow goes left, like let's say you had an arrow like this going left, so your ray is like that. Let's say this was M and T. Don't do T M like that. That's not right. Okay. You would still call that T M and put your arrow going that way. This is the way you would do it. All right, an angle is formed by two rays that share a common endpoint called the vertex. The amount of turn between the two rays is measured in degrees. So notation represented by 3 points with the vertex in the middle. So like angle ABC, where B is the vertex, angles that only have one angle at the vertex can be represented by one letter, just the vertex, or if there are numbers inside the angle, they may be represented by a number as well. So two rays basically. So here's a ray, here's a ray, there's my angle. You need 3 points on it. So W, T, S. So we could call this angle WTS or angle STW. And since there's only one angle at T, you could call it angle T. 3 different ways. If there's a number on the inside, let's say they put a 2 there, this you could also call it angle 2. Okay? Now, if you have multiple angles here, like let's say this is, T U P, and I want to talk about this angle, I cannot call this angle T. A lot of people want to call it angle T. The problem is there's 1, 2, 3, 4 angles at point T. Okay, so that wouldn't work. So we have to call this angle. We have to call this angle UTP or angle PTU. Okay, either one of those would work there. Okay, or if there's a number in the middle, you could do that also. A circle is a set of all points in a plane that are equidistant from a fixed point. So you got a point here. Let's call this point C for circle or for center. Every point that's equidistant from there would form a circle. Okay. So basically, your circle right there, every point on that circle is the same distance. So basically, if I took, a tape measure and, measured this distance, it'd be the same as this distance, which would be the same as this distance. They're all the same, anywhere from that point to the edge of the circle, all the way around. We actually call this the radius. I know it's changing. It's changing a little bit because I don't have it locked, but you see how that works there. So we would call this, since this is C right here, we would call that circle with a little dot there, C. Okay. Perpendicular line. Two lines are perpendicular if they intersect at a right angle, 90 degrees. So think of the corner of your paper, 90 degrees. So when they intersect right here, there it is. So if I call this line M and line N, if they intersect at a 90 degrees, we can say line M is perpendicular to line N. Okay. Perpendicular lines. Now, I didn't do a very good job there, because if these are lines, I should have arrows technically. So there you go. Parallel lines are two lines are parallel if they line the same plane and never intersect. When I say in the same plane, then think of the same sheet of paper or the same chalkboard or dry erase board. You don't want them on two different boards facing different directions. The same plane, the same flat surface. So, here's this one. Here's one line. And let's do this. Let me make another one. And there's another one right there. So I should use the same letters here. If AB is parallel to CD, so AB parallel to CD, we say, I should have arrows on here. AB is parallel to CD, okay? And I should have done that here too. Should have had arrows up here. Okay. A line segment is part of a line that's bounded by two distinct endpoints. It contains every point on the line between its endpoints. So a line segment has endpoints. So it would look like this. And you always name it with the endpoints. You can't use any point on the line like you can up here when there's arrows. So if this is AB, right there, this is how you would write it here. Segment AB with the line above it. Okay. So a little bit of a relationship between all this here. A ray is part of a line starting at a point and extending infinitely in one direction. It's like you chop off half of the line and just put an endpoint there. An angle is formed by two rays with a common point. So you can think of two rays that share an endpoint. Circle is defined by the set of all points at a fixed distance from a central point. Perpendicular lines and parallel lines are specific relationships between lines based on their distances and intersection points. And a line segment is a finite section of a line with 2 points as endpoints. Key takeaways. All geometric definitions build upon basic undefined notions of points, lines, and distances. Understanding these precise definitions is crucial for solving more complex geometric problems. As we go through this course, we will build on a lot of things involving points, lines, and distances. Really important to understand those terms. All right, a few more here. If you were in my class, we would split this up into 2 days, or depending on how it goes, maybe squeeze it all into one day. But I made them as two separate note sheets to have that flexibility. So we're gonna just kind of push through it in one video here, though. So more key terms: congruent segments. Congruent segments are line segments that have the same length. If segment AB is congruent to segment CD, it's written as segment AB is congruent to CD in this notation here. So here, to do this, I'll make this easy here. We'll draw a segment here. I'm going to take the same thing here. I'm going to clone it so I know it's the same exact segment there. See, same length. Now you could turn it. If it turns, if I turn it a little bit, let's see here. Maybe I could, let's see, flip it. So there. It's not in the same direction, but I could move it, turn it, rotate it, all that stuff, and it would match up right on top. So, we could say segment AB is congruent to segment CD. Okay. Congruent angles are angles that have the same measure. So, if I drew this angle, and I'm going to do this instead of using the straight line, I'm going to just sketch it there. So this is my angle. Let's say this is, A, B, C, like that, like I have right here, angle ABC. If that's the same angle measure, so I'm going to do this, I'm going to clone it, move it over here, maybe turn it a little bit, whatever, and we'll call this angle DEF. You see that they're the same still because, if I turn this thing and move it over here, it lines up exactly the same. Okay. So it was, got to get it back how it was. There we go, angle DEF. So you could say that they are congruent just like this right here. Okay. So right there, they're congruent. Congruent figures are figures that have the same shape and size. Corresponding sides and angles of congruent figures are equal. So if figure ABC is congruent to figure DEF, we write it like this. Or if triangle ABC is congruent to triangle DEF, we write it like that right there with the little triangle symbol. That means it has three sides. So here, let's draw a triangle here. Okay, here's my triangle. I'm gonna make a copy of it here. I'm gonna turn it, all that. Okay, so triangle DEF would be congruent to ABC. Now it's important that you have the corresponding angles in order. We'll get to that when we do more about this, but I just want to kind of touch on that here. Like as you notice here, pay attention here. This A, I'm going to turn this thing a little bit so you see where the A goes. So the A is now over there on the left, and it goes with the D. So you see how A and D are in the same spot, and same thing with B. B is in the middle. B corresponds to E. So when I turn this and start sliding it over there, you see the B and the E match up. Okay. So those are congruent figures. All right, a segment bisector. Segment bisector is a line, ray, or segment that divides another segment into two equal parts at its midpoint. So let's say I got a segment here. The segment bisector is going to cut this thing into two equal parts. Now you can see there that's not the left side smaller than the right, so right in the middle there. For now, I'm just gonna draw it here. So bisector here means I mark these as congruent. Those are called congruency marks. That means that this point right here, I'll call it M for my midpoint. If this is X, Y, I'm going to follow this one here. It says line X, Y. So there's X, there's Y, there's line X, Y is a segment bisector of AB, segment AB. Two congruent segments are created such that AM equals MB, or is congruent to MB, where M is the midpoint, okay? Midpoint of a line segment is the point that divides a segment into two congruent segments. So the only difference is midpoint is just what it sounds like. It's a point. The midpoint is M, okay? So that would be up here with this picture as well. An angle bisector is a line, ray, or segment that divides an angle into two congruent angles. So let's use this notation here. If BD is the angle bisector of angle ABC, so let's do it here. Here's angle ABC. So remember, put the vertex in the middle. B is right there. And if I have an angle bisector, it's going to cut this right in the middle. Think of like you're slicing a piece of pizza in half. Okay. I don't know if that's fully. And again, I'm just ballparking it. As we move on, we're not going to just estimate. We're going to use more precise things. But and then what ends up happening is this angle is congruent to this angle. These are called congruency marks for angles. Just like I have congruency marks on segments, they're just little like tick marks. You could put one mark or I could put 2 marks. That shows that these are congruent. Same thing here. I could put 1 mark on there or 2 marks. If they have the same number of marks, we know that angle, and I need a point here. I need to call that D. Ray BD is bisecting angle ABC. So we can say angle ABD is congruent to angle DBC right there, okay? These two angles are congruent. All right, skew lines are a little tricky to understand, but I think it's easier when you have a 3D 3D image, excuse me. Skew lines are lines that do not line the same plane and therefore do not intersect and are not parallel. So it would be something like this here. If you look here, like line NK and maybe like line LH. Okay, they don't intersect and they're not parallel. Okay, so KN is skew to LH. Okay, I know they're not lines because they're on a box, but if they were to continue forever, they would never touch. So I'm going to put line arrows on it. Okay, now don't do KN, line KN, don't do this. Line KN is skew to line KG because those lines clearly intersect right there at point K on a corner. Okay, and don't do, so this is a no. Don't also do this. Don't say, line KN is skew to LM, line LM, because those are parallel. They're on the same plane. They're on the same surface. They're on the top. Okay, a plane is like a side of the box. Okay, they're on the same plane. Can't do that. So that would not work. Okay, so they have to be on different planes, not intersecting as well. Okay. All right, so key takeaways, congruence relates to equality. So when you hear the word congruent, you should kind of think equal in size or measure, whether it's segments, angles, or entire figures. Bisectors are important tools in dividing geometric objects into equal parts. Something important to note, you can't bisect a line because if I have a line here, I can't cut this in half because it goes on forever. You know what I mean? So like, technically this continues on and continues on even further. So you can never really cut it in half because it's going on infinitely in both directions. Last thing, skew lines are unique in that they exist in different planes and don't interact, or intersect, I guess might be a better word than interact. So, all right, well, that's it for this lesson, and I look forward to working with you all as I progress through the illustrative math book.